All right, we are now looking at Target 8D, models of rational functions. So our 8D.3 mastery learning objective, I can write rational functions given key features by creating the factors of the numerator and the denominator, okay? So now really what we're doing is we're doing the opposite of what we did yesterday. So the big thing here is that if it gives you a vertical asymptote, the factor goes in, those are with holes. If it gives you a hole, factor goes in numerator and denominator. If it gives you a vertical asymptote, factor just goes in the denominator. In denominator. If I can write. So looking at example A, vertical asymptote at x equals 4. So I'm going to put a thing. Alright, we're going to make a fraction. So I know my vertical asymptote is at x equals 4. X equals 4 goes to x minus 4. Right, if I subtract 4 from both sides, that's how I get it equal to 0. So that goes in my denominator. I need something in my numerator. We'll usually just put a 1. So if I have a vertical asymptote at x equals 4, then 1 over x minus 4. Right? This really should be right an equation of, or write the equation of a rational function. Okay, there's many I could write here. I could write x plus 2 over x minus 4. I could write 5 over x minus 4. Right? My vertical asymptote only tells me that my denominator. It tells me nothing of my numerator. Okay? I just make it easy and just put a 1 though. Easiest way to do it. So this is f of x. You should have that part too. Alright, looking at b. F of x equals. So I have x minus 3, and then x equals 3 and x equals 2. So if x equals negative 3, that's x plus 3. If x equals 2, that's x minus 2. Right? So these are both vertical asymptotes. So x plus 3 goes here, and x minus 2 goes here. Again, I'm going to put that over 1. And then I'm going to make it look nice. So I have x squared minus 2x plus 3x minus 2. So I have x squared. Negative 2x plus 3x is plus 3x, plus 1x. Plus x minus, I can't do math today. 3 times negative 2 is negative 6, so this is minus 6. Sorry about that. Okay, so f of x equals 1 over x squared plus x minus 6. So our final answer. So we like to write it in our nice standard form instead of factored form. Alright, C, vertical asymptote at x equals negative 3, whole at x equals 2. Okay? So f x equals fraction. So I have a vertical asymptote at x equals negative 3. That means x plus 3, right? Change the sign. And since it's a vertical asymptote, it's just in my denominator. And then I have a whole at x equals 2. That means that's x minus 2. Since it's a whole, it's in both the numerator and the denominator. So simplifying this, we have x minus 2 over, again, x squared minus 2x plus 3x minus 6. Okay. So the difference between B and C is this one had a whole at x minus 2, so it had to go in both the numerator and the denominator, where this one at 2 had a vertical asymptote, so it only went in the denominator, right? So that's kind of the difference between those two. All right, last problem. This one's nice and short. Our vertical asymptote is at x equals 1, and our whole it is at x equals -1. So again, f of x equals fraction bar. Whole is at x equals -1, that's x plus 1, so that goes in both. Vertical asymptote is at x equals 1, so that's x minus 1. So that goes there. So then we have to multiply out. So I have x squared minus x so that equals x plus 1. X squared minus x plus x, right? Those are opposites. So we get x squared minus 1. One trick, if you recognize this as difference of squares, you should be able to get to this right away. You should be able to skip that step. Okay, so again, as you become more comfortable with your factoring and seeing those things, right, all this, you probably don't have to do that step, right? That's just becoming more natural. All right, that is it. Have a great rest of your day.